Hello. So I just wanted to give you a little help with a few of the things that we're going to start off this unit on or with. And one of them is the hydrologic cycle. You've all seen a diagram like this probably. This is at the very top of week 6. So let's have a peek. I'm going to, just so we can keep it as big as possible on your screen, I'm going to go ahead and make this part gradually fade up to the top so I have a little more room down below to see what's going on. This is a hydrologic cycle, or sometimes this is called the water cycle diagram, and it conceptualizes much of what's going on the whole planet. Everything from water stored in ice, although it's not quantified here, the oceans, the evaporation from the oceans, returning rainfall into the oceans. You might notice there's about a 40 unit difference between 413 and 473. So, hey, that 40 must go somewhere else, and that's what we get over the land. And so some storage of water vapor, of course, and water droplets in the clouds in the atmosphere. But over a long enough period of time, if you're measuring it, you get land precipitation, but then you also get evaporation from the land coming back up. And so there's a kind of cycling this way. And if this is all imbalanced, you might notice that 73 and 113 are also 40 units different, which kind of goes back over here, doesn't it? And so we'd expect all of this to stay kind of in balance. But if we build more reservoirs and more areas, for example, to store water behind dams to make hydroelectricity or for irrigation or just for flood control, we might end up trapping a little more of all this water on land. So you could actually see this go out of balance. And in fact, there is a net movement of water up, fresh water up in the world from building reservoirs. But there's also a net movement of water from the ice sheets and the mountains, we call glaciers, alpine glaciers, and also on the pole, Antarctica and Greenland, the continental glaciers, and that net movement of water, in this case as it melts, is nowadays going down. So you have some of this that's maybe a little out of balance. There's kind of some net flows between these. But overall, the system, as is drawn here, is in balance and works just fine. So what do we want to learn about in this particular unit? We're most interested in what we're doing with water in the continents. That's where most of us live, or islands, some of us. And so we're going to look at that. And in the case of the Pacific Northwest, this isn't too bad. Much of the precipitation forms either as snow up in the higher elevations or as rain or some combination. And some of that runs off on the surface. Some of it also infiltrates, okay? And infiltration in the most technical way means when it penetrates the ground and goes subsurface. And then as it continues to go down, that's sometimes called percolation, but that's fine. We'll use the broad term filtration. This is a simple diagram. And so what happens is eventually some of that water will become groundwater and will flow, and eventually will come out either in the oceans or a kind of similar term, but sometimes called subsurface flow, where there isn't necessarily an aquifer down below or just a whole water table. We could call that subsurface flow. That's where the water penetrates, so you get that infiltration, and then it flows under the force of gravity, subsurface, and eventually comes out in lakes and rivers and so on. And so what gives us higher quality water? Water that flows off on the surface and into a lake or a river, or water that first infiltrates and then comes out more slowly, either like this pathway or even infiltrates all the way down here and then comes out somewhere like right here. We don't have an arrow there for that, but we could have drawn one, or down here. What gives us higher quality water? Over the surface or infiltrating in first and then running under the force of gravity, eventually emerging as stream flow, lakes, rivers, and so on. Usually our highest quality water is that which infiltrates subsurface and because it's basically filtered. Okay. And so, and the question of quality of water is something we're going to later come down or look at in some detail. So this just gives us that general concept here. And here in the Pacific Northwest, we're losing a little net water from the shrinking of our glaciers, and we're also losing a little water, groundwater, especially in the Snake River Plain and other areas where we're tapping it. And so some of that groundwater flow means that there's actually less of it available, and so that means that more of it ends up going out to sea a little bit. Okay, but that's the basic idea anyway. And of course, the sun and the winds are part of this whole story. And the sun, by heating different parts of the earth, different temperatures, or the lack of sun in the winter in many places, creates the winds. So the global wind system is driven by this too. So this whole thing is all integrated. All right, so that's the hydrologic cycle. Let's go to the next unit within this. So this is the week 6, and that was a hydrologic cycle. We'll go back here and we'll click. There's a folder here we'll look at. So this is water resources materials. And I want to look next at a water resource diagram. Okay, what is that? All right, now this is one of these horrific things that every student dreads. Professors seem to love things like this. Why would we like these so much? Well, I don't like it that much, but I would say this: it's very, very useful, and it helps train us to think about all of the things that happen in a water use system. And so in that, we can think, first of all, maybe in the most general way in a system like this, where we have an input system, we do something with it, we manage it, and then we have the output, what we get from that management. And that output system basically is water-related goods and services, which enhance material and social well-being. Okay, so what is that all about? Well, let's kind of come back over here first. And the inputs of water into our system are usually either surface water, remember that running off at the very surface, or groundwater. And that's where there's a water table, basically a saturated zone somewhere down below the surface, and where it emerges at the surface, that's what we call stream flow. So these are different things, but they're connected because you can have, for example, surface water. If there's a lot of it, maybe someplace further down, it'll soak in. As it runs off the surface, it soaks in eventually, could become part of the groundwater. Or if we get groundwater rising and rising and rising, because there is so much precipitation, eventually some of it becomes at the surface, for example, in the case of stream flow, and maybe flowing into a lake. So these aren't entirely separate terms. There is interaction between them. Okay, so if you have an irrigation system and a lot of the water infiltrates, it goes back into the groundwater, okay, that's fine. But then some of that groundwater will flow out as stream flow and irrigation ditches somewhere else. So again, there's this kind of feedback here, okay, between these two. But for the most part, we can think of water as either sourcing it from the surface, like, oh, we're pumping the water out of the river or the lake, or we've got a well that's coming out of the ground. And that's usually the way we conceptualize these two somewhat different concepts, okay, is when we source them. All right, so that's the input. All right, now, institutions, technology, and capital are the management subsystem. Whew. Institutions, what does that mean? Maybe the best thing I can do is talk about these other two first. Let's imagine a river system with dams on it, some of which provide hydroelectricity, some of which provide flood control, some of which allow barges to pass through so they have locks, and so on and so forth. Okay, so what I've just described are technologies, haven't I? Dams, floodgates, passageways, turbines to make electricity. Okay, that's technology. Now, to put that technology in a river system takes capital, takes money, doesn't it? Okay, takes money. Now, when you got the investment of this capital in these technologies, it needs to be managed. And the institutions are there to do that for us. And in some cases, maybe it could be private. In the Elwha River up in northwest Washington State, Port Townsend area largely was started out as a private enterprise. But normally in really, really big river systems, and here in the Northwest, this is true, we have, and as you read Organic Machine, you're going to get pretty good at this. We have these institutions, and one of them is called the Bonneville Power Administration, and it manages the complex system of dams and locks, hydro production, flood control, all of that. It manages all of those things, okay? And that is then how we find ourselves looking at these services, right? I mentioned the irrigation, I mentioned the hydro. Of course, there's industrial and municipal uses, the water from rivers, for example, or if it's groundwater, if we were looking at a groundwater system, that could be drinking water. Some places source, sometimes Portland gets some of its water from groundwater, but mostly it's surface water. Waste carriage. Ooh, waste carriage? Yeah. One classic early industrial use of rivers was as a place to dump all the waste from the plants, okay? It becomes somebody else's problem downstream. And when there's not very much of it, it's not that big of a deal. But the bigger the plants get and the more pollution we have, that can become an issue. So how do we manage that, right? So we go back to thinking about institutions, technology, and capital. But in doing so, we have different interests, don't we? So for example, if you've got waste, then there is a kind of feedback because that's a quality issue. See, qualitative, okay? That hurts our water quality, doesn't it? Okay? And so that's a kind of feedback then if you've got waste, whether it's literally effluence of pollution into a stream from a mine waste tailings operation, or maybe the waste carriage is human waste or livestock waste, okay? There's some feedback, and some of that goes back into the surface waters. Yuck, right? And that is a lower quality of water. And so then these institutions are here, which have a kind of social, political, and economic piece to them, okay? There is an interest in that. And so the legal institutions and the legislative, judicial institutions, the legal framework, help us set up laws so we can kind of make all the system sort of work out for everybody. It's a struggle, as always, okay? So the folks, for example, who want perfect fish and wildlife habitat, they're not very interested in people who have like big logging operations where they're doing a lot of milling and dumping chemicals into the river, okay? So there's conflict, right? The people who are on the river for recreation, they'd like to drink the water in the river, but boy, they sure wouldn't imagine doing that with these kinds of uses. And so they kind of push back, right? They want at least safe water to swim in. So you have these kinds of conflicts. And when you have big water systems, you have conflict because different groups have different interests, okay? Guess what? Hydroelectricity generation does some interesting things. On one hand, it doesn't really use water. There's no water used up with hydroelectric generation, really. It's just that it has gone through a turbine and down, so it has a lower potential kinetic energy in that lower position. And so that is at its face like, well, that's a zero cost system in the sense that we still have the water. Okay, that's good, yeah. But at the same time, by putting it behind a dam for a long time, it has a longer period behind the dam. What happens to the quality of the water? So you kind of think about that. Let's see. So if there's a lot of water behind the dam in the spring and summer, what would happen? Sun shines most days. The water gets warmer. Yes. Okay. So there's a quality issue. Okay. So even hydro, by using the dam to check the runoff and then using it maybe later in the summer, we change the quality of it, even if we haven't changed the quantity. But we've changed the quantity too, though, really, haven't we? If you think about it, how have we changed the quantity of the water? By using it to make hydroelectricity. Because we've kept it behind the dam longer than it would have been in that particular position in the river, and probably covering a larger surface area because the dam, after all, has water backed up behind it, broadening out at a higher elevation, probably more surface area, more evaporation, more solar exposure. So there is less water and there's lower quality water if we define quality by its temperature. Okay, so these kind of feedbacks here. All right, So we'll contain more on the next video.